So, we're talking today about protecting your server proactively from hackers. And Vlad has joined us from Edge Web Hosting. And take it away, Vlad.
Hello, everyone. Thank you for taking the time to join in today. So we're going to cover some of the topics about protecting your infrastructure from the bad guys. And we're going to run through a number of different topics today. So first, we're going to talk about why security is important, why you need to have a security-first approach in everything that you do, and the impact of not doing so. But in the process of protecting yourself, you've got to really go and educate yourself about what are the risks and how do you integrate those things into your dev process. We're going to learn how to evaluate some of the risks of what's the impact of a data breach, how to create a secure multi-tier architecture, the importance of staying on top of patching, how do we encrypt sensitive data, so should there ever be a compromise in your data, at least what the bad guys get would be scrambled information, how to go about finding vulnerabilities, and lastly, how you can leverage outside resources to help you make some of those things happen. So we'll start off, give you a quick background about myself. I've actually been developing software since about 1981 when I originally started in BASIC as a kid, and from there just really had a passion and love for software development. And after many years, wound up starting my first IT services company in 1991, which is a software development company focused on automotive logistics. And around the time, around 1998, when we needed to have our first website hosted, I founded Edge Web Hosting, and since that time, we've been doubling the company in size every 36 months. And a little bit about Edge. What started off as one server in a closet and one person doing all the work today is about 50 technical gurus, managing about 2,000 servers. And what's interesting is today, on a daily basis, we're blocking about 15 million attacks against our customers' applications. So the reality is if you're connected to the internet, you're under attack whether you know it or not. And we manage about 600 mission-critical environments for very large, well-known brands. And our mission is simply about helping our customers leverage our people, experience, and infrastructure to help them stay up and sleep more. So let's go ahead and dive right in to a brief history of the world. So traditionally, the people who ran the world were the people with the greatest military, the greatest strength, the greatest amount of money. Here we've got the Goths, the Vandals, the Huns. But the world has changed in the last few years. And today, the geeks run the world. Because what wound up happening is the geeks don't have to be physically present to do what they do. They can be anywhere on any computer, and one single individual can cause hundreds of millions of dollars of damage if they find that one hole inside of your application and manage to get the keys to the kingdom to get at your data. So we'll start off with what's security, the definition from the Oxford English Dictionary, who happens to be one of the customers that we protect against a lot of attacks. So the dictionary definition, it's freedom from risk, danger, freedom of doubt, anxiety, and fear, something that gives or assures safety. And overall, security is really about protection. You have to feel comfortable. You've got to be able to go to sleep at night knowing someone's not going to have all of my data. But the big challenge is most companies invest almost all of their IT dollars in focusing on network security, infrastructure security, and thinking that just having a safe perimeter is enough to keep their data secure. Unfortunately, 96% of all compromised records were hacked from the outside, and the most common pathway in all cases was a public-facing website or web application. Because the challenge is network infrastructure, those types of devices can't protect against a web application that's vulnerable because the attack looks like a regular hit on your website. And the average website is attacked thousands of times a day. Most people don't take the time to look through their logs, but if you really look at it, you're going to see all kinds of crazy hits to strange URLs and people trying to exploit your parameters. Most people don't gain visibility into that until it's too late. And who's vulnerable? Well, two groups. Number one, anyone connected to the internet. And take a deep breath, because you're safe, because anyone not listening to this presentation. So it's really important to be prepared. And if the preparation and acknowledgement and understanding that this stuff is out there puts you in a mindset where you can defend against these types of issues. So security, why not? What are some of the common reasons we hear that, from developers why they don't need to focus on it? So what's the big deal? I haven't been hacked yet. I've been on the internet for a while. All this stuff's going to slow down my application. I've got deadlines. I don't have time. One of our favorites is, but I had a firewall, and I thought the cloud was safe, and security is IT's job, not mine. The challenge is, if we go back to the previous slide, it's our web applications that have a tendency to create the biggest security risks, and that's why we have to be the most mindful about security. So when folks don't focus on security, here's some of the recent incidents. I'm sure everybody's heard about Target in the news, where they've talked about 110 million customer records, credit cards potentially being exposed. That was an application layer attack of a website. I think everyone remembers when Sony's PlayStation Network was down for a considerable amount of time, lost 77 million records. Snapchat, Living Social, I believe last year lost data for about 50 million users. Neiman Marcus was just in the news 2 days ago about a potential data breach. And what's interesting is, in each one of these cases, tens of millions of records exposed. All of these happened at the website level. Someone hit a website, crafted a particular type of URL, got into the platform, and successfully accessed all of this data. Now, one of the things people are thinking is, this has got to be a really lucrative business. People have to be making insane amounts of money at it. Well, that used to be the case many years ago. But the reality is, there's so much compromised data out there that the value of somebody's identity has really come down in a significant way, where before you used to pay thousands of dollars to get someone's name, credit card number, social security, mother's maiden name, address.
Well, what's it now, Vlad? $100?
It's actually interesting. It's $13.
No way.
$13 is what someone's identity is worth today, which is why when you see these numbers, 13 times 110 million customer records becomes a significant amount of money. And that's why a lot of these criminal organizations are targeting this, where they used to go after just a few hundred or a few thousand names. As the value came down, they had to compromise more records to get the same output. So just in something like the Target attack alone, I mean, think of the implications of 110 million times $13 a record. So it's really amazing that the value is this low, because there's now more compromised data than criminals who have the time to exploit the data, which is part of the problem. We'd love to see that price go back up, because people were no longer able to compromise these systems.
And I guess it's gone down because there's so much hacking going on. It's not that the risk has gone down.
Exactly. The criminals just don't have enough time to use all these stolen credit card numbers.
Okay. So let's just, I'm kind of curious what security issues people on the webinar are seeing. So let's just do a poll. What security issues do you see? And check all apply: cross-site scripting, denial of service attack, cold fusion configuration vulnerable, database not secure, or some other issue. And I'll close the poll in a few seconds. 3, 2, 1, and closing the poll. And looks like cross-site scripting is the #1 issue, with the other ones following closely behind. So,
okay.
Very interesting.
And that is one of the top 3 that we see. It's so, if folks who aren't familiar with cross-site scripting, it's when you pass a parameter inside of a URL, and then the code doesn't sanitize that input, so you're able to generate JavaScript that runs locally on the customer's browser, which you can then use to steal their credentials. It is one of the most common attacks that we see out there, followed by SQL injection, and then lastly path traversal attacks. Now, I didn't put DDoS on this list, but DDoS is also a fairly common type of attack. But that's more of a just doing damage and not as much of a data breach issue, unless there are times where the hackers and attackers have used a DDoS as a distraction while they go and carry out one of these other types of attacks.
And just for folks who don't know, DDoS is distributed denial of service. That's where they have like a whole farm of robot computers that are attacking your server.
I think that the largest one that we've seen against us to date was somewhere around 6 million computers attacking one of our customers and driving somewhere close to 27 gigabits of internet traffic.
Wow.
So the folks who know how to do this stuff are really serious. They know what they're doing, and they know how to cause real harm. And it doesn't take a large army of folks to do it. I believe there was a case just a few months ago where a guy in a minivan in Spain was able to drive enough traffic where they not only took down a major anti-spam vendor, they almost took down the entire internet. And that was just one guy in a minivan using a wireless connection, using a very specific type of attack.
Wow.
So what can we do about it? So number one, we've got to realize that web security is not optional. Web security should be built into everything that we do, because building it in the beginning into your applications is much easier than integrated after the application's gone out the door. And you have to allocate time. I know we all spend time, learning a new framework, learning new languages, learning new technologies. But how many of us are actually allocating time to just focus on security? And what are the common attack vectors? What are we putting inside of our code to make sure that we're not vulnerable to them? And it's got to be integrated into your dev test life cycle. So you roll out your application. Is vulnerability scanning of your app prior to putting it out into production a standard part of what you do? Because if the code's not tested, the probability is it's vulnerable. And lastly, learn the buzzwords, because there's a lot of them out there, and if you can't talk the talk, you're going to have a hard time, walking the walk. You know that cross-site scripting is XSS. What is SQL injection? What's a path traversal? What's a DDoS? Learn a lot of these buzzwords, and I'm going to provide you guys with some information on where you can go to really spend some time to educate yourself, and specifically, around web technologies, and also specifically around Cold Fusion. So here's some of those resources. One of the things you should learn to be familiar with is what's called the OWASP Top 10. So OWASP is an organization that tracks trends for types of attacks, and they are showing their top 10, and that evolves on an annual basis, of what are the most common attack vectors that attackers are using to try to exploit the data inside of applications. So it's good to be very well versed. Well, there's maybe 400 or 500 different ways to attack an application. The common ways are the must-do. So you must have protection for, again, cross-site scripting, SQL injection. But look through those top 10 and see, if you can actually exploit your own application using those things. And then they also they've got a great guide on very Cold Fusion specific resources. So learning what are the strategies, what can you actually put into your code, what are the tags you use to protect against certain types of attacks. And there's links to code samples here on the OWASP website. And lastly, stay up with Adobe, and they've got a good page talking about security best practices, what to do, what's out there for security patches is the second link. And then Pete Freytag also has got a good blog that talks about a lot of different security issues, and he even has a web application firewall for Cold Fusion.
Have you noticed much difference in the last year with Adobe's focus on security since the problems at the beginning of last year?
Well, we were a little surprised that last year they had 3 very similar incidents, and I think that really taught them some lessons about diving deeper into their code, because I believe the last one was in November of 2013, but it was very similar to the incident before it and very similar to the incident before that. And I think that stung them a little bit. They weren't expecting to have those kind of issues, and since that time, they have really changed their focus to look at the platform, make sure they're looking at security as part of their approach, because nothing causes problems for a product like a new security risk. And I think they really understand that and have understood the business impact of those incidents, and I think they're in a position where I don't believe they ever want that to happen again. So sometimes when you have an incident like what they had last year, it actually allows the company to refocus on what's really important, and obviously security is there.
Great.
So after you've spent time educating yourself, what you really need to understand is, what's the risk? Do you actually know what data your application is managing? Are you just building a screen, or do you actually understand, hey, this is healthcare data, this is credit cards? Could this data be used for a malicious purpose? I mean, because generally, if you're putting up, data about your VCR collection from the 1980s, nobody really cares. But if you could have data that's really important, what's the damage it's going to do? What's the harm to your customers? What's the harm to your company? What could happen to your brand or reputation? I mean, I know in the Living Social hack, and I know some of the folks that worked over there, the damage that was done to their brand was just irreparable. I mean, eventually they will repair it, but it will take years for the impact. And lastly, are you prepared? Do you know what to do? Because a lot of times having a plan is half the battle. You don't want to be responding to the incident as it's happening. You want to whiteboard this. Figure out, what are we going to do? Let's say, imagine today we had a data breach. You should have a formal incident response plan, and it doesn't have to be that complicated. Just Google online. There's plenty of them. It's, where are we going to look? How are we going to communicate to our customers? How are we going to communicate to the public? What are we going to do after the breach? And you want to have that plan together, because there's nothing like preparation to make you more successful. Be very clear when evaluating your risks. Now, once you understand what are some of the ways we're going to get attacked, you understand what's the impact of them being successful, you want to create what's called a multi-tier architecture. And what I want you to think about is Fort Knox, right? There's a lot of gold inside of Fort Knox, but you don't hear a lot of criminals going and knocking the place over and taking the gold out. You see them, maybe going to a jewelry store or going to a bank, but they're never going to go to Fort Knox, although, man, there's a lot of gold in there. And what we like to talk about is there's no one defense that works in all cases. What's really important is a multi-tiered approach. So if you think about what happens when you drive up to Fort Knox, first there's going to be some gates, and then there's going to be barbed wire, and then there's going to be some guards, and then there's going to be some dogs, and then there's going to be another set of guards and a set of doors and another set of vaults. And by the time you've looked at this and said, how the heck am I ever going to get in here? The level of effort, although there's a lot of gold in there, it just doesn't really make sense. Let me just go right next door and knock over this jewelry store. And criminals think the same way. So the key is having a multi-tiered approach. Then every time the criminal passes another level, they hit another roadblock. And eventually, they're going to give up. They're going to go to the website that's somewhere else that's much easier to hack than yours.
Well, that explains why there aren't many jewelry stores next door to Fort Knox anymore.
There you go. So, we break this up really into 4 categories. You've got your network, your web servers, your database servers, and then what are some of the best, service practices that you can have. So on the network side of things, you want to look at things like denial of service protection, and there are vendors out there like Cloudflare that do that reasonably inexpensive. You want to have perimeter firewalls in your networks. If you're inside of a larger organization, that may be something that's managed by someone else. And you want to have some level of intrusion detection and prevention. I mean, that is really key. Of the 15 million attacks that we stop, about 13 million of them are actually stopped in this first network tier. And then as we go down into the deeper and deeper levels, we're filtering out less and less attacks because we're stopping the broad population of the bad guys. One of the other things that you would want to consider, and the banks have really adopted this, but more and more people are going in this direction, is dual-factor authentication, where you can either use your cell phone or a key fob as a secondary form of authentication. So in case your username and password gets stolen, which is pretty easy to do, especially with cross-site scripting, you have this second mechanism for authentication. And there's companies out there like Duo Security is the one we happen to use, where you can easily plug that into your application through an API, and for a very low cost, give your users the ability to have two factors. So besides grabbing their username and password, you've got to find the user, mug them, grab their cell phone or their key fob before you can actually gain access to the data. Once you've filtered out the majority of your attacks there, you then have to look at your web servers, and we'll dive a little bit deeper into the web servers. But you could have your own firewall. You've got to follow best practices for hardening your web servers, and we'll go into that. One of the things that's really important, and we stop the next major batch of attacks, is what's called web application firewalls. There are many vendors out there that have these types of devices, either as hardware or software. Many of them are not very expensive. But when you have an issue, the web application firewall may be the thing that saves you. You want to have antivirus on all of your systems, so if someone does get on, they can't get their actual virus on your machine. You want to have separation of your web servers and database servers, where the web servers are public-facing, but all your data is in a separate internal network zone, and there's firewalls between your web and your database servers. And you've got to have good logging. There's nothing more important than good comprehensive logging, because if you should ever have a data breach, logs are the only way you're going to find out, number one, how they got in so you can stop them, and number two, what they got so you can do something about it. And then there are other service best practices. You've got to make sure your servers are patched, you have vulnerability scanning, you're encrypting your data. And one of the things that's a little bit newer, but many of our compliance customers do, is what's called file integrity monitoring, where you take a snapshot of your files every single day, just a checksum, and if any critical file changes, you record that, because a lot of times a hacker will get onto a system, place their backdoor on there, and it's hidden and no one can find it, and it's buried in the deepest, darkest depths of your server, and no one can ever find it. And the only way you can find it is by taking two snapshots, overlaying them one over another, and seeing what's changed over a period of time. So that's what we mean by the multi-tier approach. And this isn't the recipe for success. This is just, it happens to be how we do it, but there are many ways to do this. The key is put as many layers between your data and the attacker as possible to just make them give up before they get to your information.
So I'm kind of curious what version of Cold Fusion people are running. So let's just ask people that. We've got another poll up here, whether you're using Cold Fusion 10, 9, 8 or earlier, or some other version like Raylo or Blue Dragon. So I'll go ahead and close the poll in a few seconds. Going to close in 3, 2, 1. And looks like most people are still on CF9, though CF10 is catching up. Do you have any comment on whether the different versions of Cold Fusion make any difference?
Not really. I mean, it's interesting because well, first of all, I'll also say, interestingly enough, the majority of our Cold Fusion customers are also on 9, although we are seeing 10 growing. But the recent issues that were found were actually found in multiple versions of Cold Fusion, so I believe they affected 7, 8, 9, and 10. So my expectation is after Adobe had this number of issues, as they start doing new releases of 10 and started moving into 11, I actually expect to see more security inside of Cold Fusion, more focus on it, and less incidents from them.
Great. So let's go on to the web application firewall that you mentioned earlier.
Okay, great. So I can't stress how important a web application firewall is. And let me tell you a story about one of our customers. We had one of our customers had, lots of servers, lots of infrastructure, lots of security, great coders, great technical processes, and this was actually before web application firewalls were very commonly available. And one day, they decided they were going to hire a summer intern. And they gave that summer intern one project. He did the project and went along in his merry way, all back off to college after the summer was over. A few months later, a hacker was trying to attack their application. He was hitting every piece of their app they could and just finding everything to be rock solid because they had focused so much on security and made it part of their process. And he found the one page this one summer intern had developed and used that one page to go in and compromise an entire cluster of mission-critical servers because this tool didn't exist at that time. So this was many years ago. Web application firewalls look for patterns of attack. And for those of you who code, if you're familiar with regex, it's really looking for regex patterns. So I'll use a very simple example. Let's say I want to do a cross-site scripting attack. Inside of your parameter, I'm going to say, bracket script, bracket, and then whatever JavaScript I want to run that I'm hoping to render. Well, a web application firewall will simply say, I generally shouldn't have a script command inside of my URL, so I'm just going to gracefully block this request. Or if it's a SQL injection attack where page equals 1, plus 1 equals 1, it should say, I really shouldn't have a plus or plus after a parameter. So it's not intelligent where it understands what a SQL injection attack is, but there are certain patterns that it can pick up through sophisticated regex and say, that looks really suspicious. And I don't think I'm going to let this through, and I'm going to block it. I'm going to log it somewhere, and then the developers can come back and say, what, that's okay. On this one page, we actually intended to do this because it's providing some type of functionality to the application, and you do something what's called whitelist a particular URL against a particular pattern. But for all of you that understand regex, that's all a web application firewall does. It runs a request through a list of patterns and say, does it match or fail? And if it matches, I'm going to block. And if it doesn't match anything, I'm just going to let the request through.
And I assume that they keep the list of patterns up to date for you. Is that right, Vlad?
Correct. All the vendors have updates. And what's interesting is they don't have to update as much as you would think, because once you say don't allow a select, semicolon select after a parameter, it tends to stop a lot of attacks. But they keep them up to date, and there's literally hundreds of these patterns. On Linux, there's mod security. There's a couple applications like .defender is one that's a third-party product that works very well. Pete Freytag has FuseGuard 2.1 that's Cold Fusion specific. TrustWave actually has an appliance that you can put in front of your web server. And I put in a link here to OAuth. They have a list of different application firewall vendors. But I would say if you can spend a few $100s and put this in front of your application, this could save you tens of thousands of dollars down the road just because you forgot to add one CF HTTP query param or sanitizing your scripts and your parameters. This one thing could save you if you make one mistake. So we've always very strongly recommend all applications, secure or not, get this because it's very easy to just put semicolon delete from customers, semicolon right after your parameter, and if your app does things in a very specific way, the attacker has just deleted your customer table. So let's move on to staying on top of patches. So why do we patch? Because if you don't, getting hacked is almost guaranteed. When vendors release patches, at the same time they'll usually release details on how the exploit occurs. The attackers will simply take that, write an automated script, and start scanning for computers over the entire internet that are vulnerable to this public vulnerability because most folks don't take the time to patch. So we found that customers who don't patch have a much greater probability, probably 80% greater probability of getting hacked than those who do take the time to patch. And what should you patch? Now, one of the things is this is really important. Don't just focus on Cold Fusion. If you have PHP, you could have .NET, you could have Ruby on Rails, you could have a number of different applications running on your server. An attacker only needs to exploit one of them to get at your server and your data. Make sure you've got a comprehensive list of all the application platforms that run in your environment, and from there you have a patching schedule for each one of them. One of the things I will caution you, be very careful when patching Cold Fusion and PHP. You want to make sure that it doesn't have an impact in your application. It very often does, so you want to make sure you integrate that into your software development lifecycle, where you'll actually go test a patch on a dev machine, make sure it doesn't impact your application, and then push it out to production. You always want to keep your operating systems up to date, and most of the today's operating systems make that very easy. If you're on Linux, you can run an up-to-date. If you're on Windows, you simply run Windows patching, and it's next, finished. This stuff isn't hard, but it's still important. You also always want to make sure that you patch your database servers. A lot of folks say, well, we can't ever afford any downtime. And there have been a number of security incidents where a vulnerability within a database server itself has been exploited to get at the data. So you want to keep your database servers up to date. Obviously, the network infrastructure, making sure that that's all hardened. And then lastly, and this is one of the places where we see the greatest number of successful attacks, is actually third-party components. So, for example, you're running a WordPress blog and you have some third-party component, and the third-party component gets hacked. Although you've kept all your code up to date, all your servers up to date, these third-party components also get compromised. So you want to make sure you're keeping them up to date, and a lot of times by having a web application firewall, that buys you the time that you need to protect yourself. And then lastly, you should have a patching schedule. What's appropriate for you, monthly, quarterly? We never suggest that it's never. There's some folks, if you can't take the downtime, at least schedule time to patch quarterly. Our suggestion is always patch monthly for customers.
I mean, if you can't take the time to patch, do you have the time to deal with someone hacking into your server and crashing it and all that stuff? So, it's I don't know why people don't patch.
Exactly. The time it takes to clean up the mess is much greater than all of the time that you will spend patching the environment over its entire lifetime.
So I know we're going to talk about. Thanks, Vlad. I know we're going to talk about the database, what we can do there. So I'm kind of curious what databases people are using on production. So let's just ask a poll on that and check all that apply: SQL Server, MySQL, Oracle, Access, or some other database. And I'll go ahead and close the poll in a few seconds. 3, 2, 1, and looks like most folks, overwhelming majority, are on SQL Server, followed by a lesser number using MySQL, Oracle, and still have some folks using Access and some other databases. So kind of interesting. So what can we do? If someone's got in there, what kind of encryption can we do? And does the database you use make any difference there?
There's certainly modules for the different databases that allow you to do the encryption within the database itself. Interestingly enough, it's one of the things that we don't suggest that you do. Because the challenge you wind up having is, if the database handles the encryption, it also handles the decryption. So if I did select star from credit cards and got back all the results in a decrypted form, that means that if I figure out a way to run that query by compromising your code, the fact that it's encrypted in the database doesn't matter, because the database has presented that data already decrypted back to your application. So what we try to recommend folks do is encrypt at the application layer. Let your application actually control who has access, when they have access, and do all the encryption and decryption. And be really careful how you store your keys. I mean, don't think just because you put it inside of an encrypted CFM file or an encrypted .NET file that someone can't recover that. So try to craft a strategy that will work, so that if an attacker, using the methodology that if an attacker got on, how could I keep them from getting my keys? That's really, really important. So be careful how you store your keys. And then lastly, after you encrypt inside the database, we also suggest that once you do your backups, encrypt your backups as well. Because if an attacker ever got to your database backups, if something wasn't encrypted for some reason, really you want to give them a scrambled mess. Because again, the level of effort should exceed the value of the data, and that's the pattern that we follow consistently and recommend our customers do as well.
So if you're saying do the encryption through your Cold Fusion code, but be careful where you store the keys, where can people store the keys?
It depends. It can be application, specific. I mean, you can store it in a different field. You can have multi-tiered encryption. You can have a web service that returns the keys to you versus some methodology. So that's a little bit difficult for me to say because it's very application specific, but you don't want it, let's say, in your application.cfm as a variable, because as soon as I've got your application.cfm file, I'm just going to decrypt it and I'll have the keys to your data.
That makes
so
sense.
Figure out a way to obfuscate it somewhere. It could be buried somewhere within your application, somewhere on a different server that you pull it in from, but figure out some way to disconnect the data and the keys. Okay, so let's go to hardening your server. And there's a lot of best practice documents out there about this. But first thing you want to do is limit administrative logins from the outside. So for Windows, you want to make sure that you change the administrator password, because if I already know your password's administrator, if your username's administrator, I can start just trying to brute force your password. It's much more effective if I've got to brute force both your username and your password. Or on Linux servers, you want to disable remote logins from root. You want to have a user mode login that you then have to do what's called a sudo to do that. So if you're not a sysadmin, ask the folks who administer your server if that's something that they can do. Each one of the OSs has basic hardening guidelines, and if you Google hardening Windows or hardening Linux, I didn't want to be redundant on this presentation to do that, but if you just follow this, they usually have a comprehensive and very simple guide of here are the features you should turn off if this is a public-facing service. Don't run any services that aren't supposed to be exposed. Use complex passwords to prevent brute force. You want to lock down your application servers. So, for example, follow the Cold Fusion lockdown guides. Let's say in the recent batch of Cold Fusion incidents, everyone who followed the lockdown guide was completely unaffected by any of those incidents, including all of our customers here. Since you actually follow that pattern, they couldn't even attack the compromised code because it was already secured from the outside. And the same thing exists for PHP. For example, lock down your phpMyAdmin or lock down your WordPress admin by IP address. Consider using SSL. Consider using things like username password authentication prior to the admin. And you definitely want to make sure all of your admin interfaces are locked down for everything, and then especially the CFIDE, because if someone finds another vulnerability inside of Cold Fusion, pretty good chance it's going to be there. The other thing
That's a great point,
of,
Vlad, and Russ Michaels is saying, you need to lock down any things like Mura or other CMSs you have, as well as WordPress, or basically anything where you've got an admin interface, because a lot of these admins have some powerful tools inside them where you can upload files and all kinds of wacky stuff. So once someone's broken into your admin, you're basically toast.
Absolutely, Russ is spot on. And and again, it's a multi-tiered approach. It's to lock down the folders, filter them by IP addresses, use SSLs on the admins, use complex passwords, do IP filters. All of those things combined just continue to hit roadblock. Make more and more roadblocks for someone, for an attacker before they attack you or and get to your customer's data. One of the other things I always warn people just to be mindful of, there were some security patches that were created by Adobe for Cold Fusion that put a post variable limit inside of Cold Fusion, which is adjustable through the XML, but a lot of our customers actually got hit by that, where they were posting thousands of fields in a form post as just a way that they routinely run in their application, and the attackers were going in and posting tens of thousands of variables to try to crash Cold Fusion servers. So just be mindful of, after you patch Cold Fusion, if you have places within your application that are doing large posts of large number of fields, and it comes back with just a blank screen and it's inexplicable, just be mindful that there is something out there that you can change to increase that value.
And you mentioned using strong passwords, and has that changed in the last few years? Because it used to be, you had like a random bunch of 8 characters, it was enough, but I think I've read that can be cracked now.
It really can. So we're increasing password complexity sizes, saying maybe use uppercase and a lowercase, go to 10, add a punctuation mark. And the thing is, each time you add another variable in the equation, it's an exponentially more tries they need to get at your password, because it's that much more random.
And that's partly because computers are getting faster, but are they also like doing distributed, they've got these bot farms of millions of things. I guess they could use those to like really have a supercomputer to crack your passwords if they felt like it.
Absolutely. There's an interesting strategy now that they use called rainbow tables, where they know what algorithm the algorithm is used for encryption. So they take every combination and actually create what the outputs would be, and then they're doing simple string comparisons to actually figure out what the decrypted data is, instead of having to decrypt the string, which lets them much more efficiently decrypt data. And each time you add another character or punctuation or case, it just makes it that many more tries they have to do to make it more difficult to get at the data than the level of effort required.
Right, and that's not just for your admin passwords, that's in your code for the user passwords as well, I assume, that you force users to have strong passwords and don't stick like common names or words into their passwords.
Absolutely. And then if you can introduce dual-factor authentication, that takes so many issues out of the equation that even if someone doesn't use a strong password, you can still have a certain level of protection. But I mean, I don't know if anyone saw the articles out there from Adobe when their database was compromised. The most common passwords were password 12345, 1234556, test, test 123. I mean, just all the stuff that you shouldn't have up there. And I'm sure that's because all those things were their legacy. But just be mindful that even if you have legacy data, sometimes it's worth the effort of asking customers to change password to keep up with security trends.
That's a great suggestion. There isn't some kind of tag you can use that would detect if the user is an idiot?
I know that there are tools out there. It's not something that I personally code, but there are.
You mean they have to go through an intelligence test before they can use your app?
That is always helpful. Always helpful.
Okay.
But there are definitely third-party libraries out there that will test your password complexity and let you know whether it's strong or weak, and report that back to the customer.
Great. So I'm kind of curious, what people are currently doing to lock down their apps. So I've got another poll here. Have you follow the Cold Fusion lockdown guide? Have you encrypted your credit cards and other sensitive data? Are you encrypting backups? Are you applying patches as they come out each month? And have you audited your code for security holes, including any code written by summer interns, as you mentioned? So I'll go ahead and close the poll in a few seconds. 3, 2, 1. And it's impressive. 70% of the people on the webinar have encrypted their data and locked down their Cold Fusion server. A lot fewer, though, have encrypted their data. But I'm glad to see most people have been applying patches, 90% of people doing that. So great job, guys. So what's next, Vlad?
So next we're going to talk about scanning your applications frequently. So by making vulnerability testing a standard part of your dev, test, rollout to production process, can really help identify some of those code problems caused by summer interns. Now, there's no one tool that has the magic formula to find every single vulnerability, and you have to have that security-first approach in everything that you do. But all it takes is one missing line of code to get you there. And a lot of these products can actually go and find, everything on the OWASP top 10, but they'll go in and scan for a couple hundred different types of vulnerabilities and provide you a report. So some of the tools out there, I know Tenable actually has an open source or free version of I don't think it's open source, I'm sorry, it's free version of their product. They have commercial versions. I know Pete has HackMyCF, which is Cold Fusion specific. One of the ones we use very often is a company called TrustWave, and they have a vulnerability scanner that's very good. That'll go in, scan your application for I think like 4,000 or 5,000 different types of vulnerabilities, and see what see what it can find out there. And it actually gives you back a really comprehensive report that says, here's what I hit, here's what I tried, it's vulnerable, here's how you can reproduce the problem, and here's some good reading on how to fix this specific type of problem. So that's on the TrustWave reports. I think HackMyCF does the same thing as well, and I believe that'll even pick up some missing patches. And Tenable's, also a great tool, very similar to the TrustWave, but maybe not as deep as the TrustWave product. But again, they have a free version that you can actually test your application with. And then we recommend you scan at least once a month, just as a standard course of doing business. Every month, part of your process is we run the scan and we review the reports. A lot of folks forget that second step of review the reports and see what it found. They just get comfortable with the fact that scanning is happening. So not only should you scan when you push out to production, you also need to do this process on a monthly basis, because if something slips its way in, this is the only way that you're going to find it. And the last piece of advice here I didn't put up on the screen, but I should mention is, and this is really critical, turn off all of your security devices from the scanner product. Because if you've got this great intrusion detection and prevention system, and you've got these great web application firewalls and all that stuff in place, that can potentially mask the problem. So you want to whitelist whatever your testing tool is, so that it doesn't go through intrusion detection and prevention, it doesn't get filtered by the web application firewall, so that your tool can actually find those vulnerabilities before the attackers do. Because at some point, they'll find a signature that the scanning vendor didn't have in their system, and they'll figure out a way to compromise your code, or that the IDS, IPS, or the WAF didn't have a signature for, and they'll figure out a way to compromise your code. So make sure that you add that whitelist. That's a really important piece to making sure that you're going to get good data.
So that comes back to the point you said, have multiple levels of security. Don't just rely on one level.
Exactly, but then turn all of them off for your scanner, so your scanner can actually see what your code looks like without all those levels of security. Because if someone manages to penetrate one of those levels of security, they now have enhanced visibility.
So it's almost like if you have a house, you not only lock the front door, but you lock all the interior doors at night, so that if someone did break in, they can't get very far.
Exactly. Okay. And our last slide, leveraging others. So one of the things you need to ask is, some of you I'm sure have your own environments, and others of you work with larger IT departments, and you might have some people in charge of servers and other people in charge of the network. So learn how to ask the right questions. The first part of that is educating yourself, which we covered in the very beginning, so you kind of understand the buzzwords, what are the things you're going to ask for. But you can start to ask questions, and these are just a few that we always suggest the folks ask. Do I have protection from distributed denial of service attacks? What happens if 3 million computers go and want to attack my server at once? Are there any intrusion detection and intrusion prevention systems in place to try to filter the stuff out before it even gets to my application? Is my server isolated from others? I mean, one of the problems that we see from a lot of folks out there is they'll take all their servers, they'll put them all in one area, and once an attacker makes it through all the security gear and gets on one computer, they actually hack everything from the inside out. So you want to make sure that your stuff, if it's really important and has really sensitive information, it's isolated from other servers, so the server right next to yours has no additional visibility into what you do than the guy that might be attacking your web application from China. Are your web and database servers in different network zones? And that's really important because you always want to separate your web and your database servers in high security environments, because your web is public facing. And if the attacker manages to get on your web server, you want to have that firewall between your web and your database server to keep them out of your data, because just because they can see your web application and your .cfm code doesn't mean that they've actually by default got access to your database server or your database backups. So that's why that's so important. We talked about the web application firewall, and lastly, it's really what are we going to do in case of a data breach? Do we have a plan? Are we prepared? Do we know how to respond? Do we know where to look? So that's really the place. Those are the types of broad questions you want to make sure you have answers to before you put any type of secure information on the internet. And if you don't want to know about any of this stuff, the shameless plug, just call us, and we're here to help.
Great. So we're going to go into Q&A in a moment. You can ask questions on the question part of the control panel on the right-hand side of your screen. But meanwhile, I just want to ask one final poll, which is what people are concerned about with security in your apps, whether it's, and check all that apply, it's whether you're concerned about users being upset or losing clients, or that you're going to get server crashes, or looks bad to senior management, or that you're going to get revenue loss. So we'll go ahead and close the poll in a few seconds. 3, 2, 1, and closing the poll. And well, it looks like people are concerned about most of those things. So it's a very important issue, security. It can really cause bad day, bad week, bad year if you have a security breach of this nature. So we're going to go into Q&A. We've got a few questions here. You can ask your questions in the Q&A section on the right-hand side. So the first question we have is, do you have any recommendations on having a web application firewall server versus a server plugin? You know, should you use a hardware server or a plugin?
You know, we have customers that use both, and a lot of it depends on the web technology that you're using and if there's a plugin. So, for example, if you're using something like, you know, Pete Freitag's product, that's specific to Cold Fusion, but that doesn't protect IIS, PHP, and .NET. So we happen to use a product called .Defender, which is actually a plugin that'll plug into either Apache or into IIS to have all of those web services protected. The place where we typically see folks using an appliance is if they have a non-standard web server that doesn't have a plugin available, Nginx, or they're using just pure Tomcat or JBoss, and there doesn't happen to be a plugin that's available for that specific type of application server. The only way to really get that type of defense effectively is to have an appliance in front. We don't like appliances as much, just typically because it's another device in the chain to fail, and if we can have the same type of protection through software versus hardware, we can achieve the same result, which is easier to manage without another device that we have to have redundancy for in front of the application. That's a great question.
Okay, I've got another question here from Arnold Young. He's saying, beside web applications, what about cloud applications through RDP technology like Citrix or terminal services or Go Global? How can you secure those kind of things?
Well, a couple of different ways. Number one, you never want to put a service that grants remote access to the server on the public internet without a firewall. That is a hands-down no-no. I mean, one of the things I'll tell you we do here, we actually scan our own network from the outside looking for the same types of things that a customer would look for. So, for example, open anonymous FTP servers or open RDP, remote desktop servers or Citrix servers, any of those types of services that could be exposed. We simply don't permit those on our network. Under any circumstances, you have to have a firewall with a VPN, and if it's a compliance-based environment, we add dual-factor authentication to get onto the network prior to actually gaining access and even being able to try to connect to RDP. One of the reasons why, of those 15 million attacks a day, probably around 500,000 of them are folks looking for remote desktop servers that they can brute force. And it's that significant of a problem, which is why I never suggest that you have it open. And if you do have it open, make sure you at least have some type of IP filter in place as a minimal level of protection.
Great. So another question here. Someone is using Cold Fusion 9, Windows Server 2008, 64 bits, and they don't have a second system to practice the upgrade to 9.2 and the lockdown tasks. So how can they do this without taking down their production server while they're practicing?
Sure, great question. So one of the things you can do, I mean, Adobe has a free version of, the Developer Edition. You can install IIS on your local computer, install Cold Fusion on your local computer, and if you put everything in the same paths, you should, in theory, it doesn't work 100% of the time, but in theory, be able to copy the Cold Fusion folder down in exactly the same way to your local PC, run the binding tool to bind it to your local copy of IIS, and if your application actually functions from then, at that point you can see what are the implications of running 902 by applying the patches locally and making sure that you have clarity around the process and a clear understanding of what impact is it going to have on your application. And if you do a lot of posts between 9 and 902, that was one of the fixes that they had with one of the patches, I believe, in 902. So keep an eye out for that post variable limit if that's something that you're doing within your application.
Great. And someone else is asking, are there any existing Cold Fusion security issues that haven't been resolved or by Adobe or Raylo or whoever manufactures the version of Cold Fusion you're using?
Not that we know about to date, but I mean, I can tell you that there are still people getting compromised through the last batch of vulnerabilities, and we still see hundreds of thousands of attempts per day on our intrusion detection systems of people trying. We simply block the attempt. So just because Adobe's released a patch doesn't mean that everyone's safe, and it also doesn't mean that there isn't something else out there that we don't know about and no one knows about, including Adobe. One of the incidents we had many years ago was there was actually a vulnerability inside of Cold Fusion no one knew about, and we saw some attackers actually use that to penetrate a number of servers successfully. And we had to work with Adobe to figure out what the heck are these guys doing. And we were the first ones to give that information to Adobe. They released a patch for it pretty shortly thereafter. But the key is, if you follow a lot of these methodologies of hardening your server, locking things down, keeping the things that should never be connected to the outside lockdown, like your admin interfaces and your RDP, you'll actually find that you have reduced your risk so much that, again, it's easier to go next door and knock over the jewelry store than it is Fort Knox. They're going to go for the lowest common denominator because they've got to get so much data to create enough value to make the level of effort worth it at $13 an identity. And there's so many people out there that aren't out there monitoring their security and being mindful of it. You just want to be a much more difficult target.
I've got this is a comment from Russ saying, older versions of CF, because they're no longer supported, they won't have their holes fixed. Do you have any response on that, or is there a version of Cold Fusion you shouldn't be running because it's so old?
I think 8 is the worst case scenario. 9 is really the requirement that we have for any environment that has sensitive data. We won't install 6 or 7 on our network at all, just because the risk is too great. And Russ is 100% correct, and you can mitigate a little bit of the risk by, doing some of the blocking, with CFIDE and some of the security devices at the perimeter. But ultimately, Adobe made the decision to no longer release patches for those older products because they don't want to duplicate effort and they want to encourage people to upgrade. So if you have the option, be at least on version 9 to make sure that you're in a good place.
And what about the JVM? Should you update your Java virtual machine as well, or doesn't that matter? Or?
We typically do, just as a matter of practice, that we want to keep our customers in a reasonably current JVM. Plus, there were some bugs in some of the older versions of the JVM, and I believe there were a couple security compromises. But it never hurts to be on a much more recent version. I believe most of our Cold Fusion 9 servers are still using variants, higher variants of 1.6, and most of our Cold Fusion 10 customers are using version 1.7 unless they have a specific code issue. Mm-hmm. But it's not something we always try to keep things fairly current, so it's less of an issue. But I believe there have been some incidents in the past where something in Java has been used to compromise servers. So you want to keep your JVM up to date as well.
Great. Dan has a question. Should we be concerned that the source code for Cold Fusion was hacked, stolen from Adobe, and potentially available to other hackers to figure out how to reverse engineer and hack into our servers?
Me personally, I'm less concerned about that, because the more things they find, the more patches Adobe can release, and the greater the probability of creating a stronger product. It's been one of the things that's made platforms like PHP much stronger, because you can have so many more eyes on the platform that a lot of the security vulnerabilities get fixed faster. So while initially there may be greater risk, I think long-term, this has really changed Adobe's stance, which will force them to create a much stronger, much more secure, much more robust product. So it's unfortunate, and I'm sure they don't like the release of their IP, but at the end of the day, if a hacker does find something, whether they have the code or not, eventually someone will find that same hole, so better find it sooner, get a patch for it, and get it out there into the wild, and making sure that all the servers are secure.
I know we've talked a lot about Cold Fusion issues, but have you seen a lot of issues with PHP or WordPress or some of the other systems people run?
Well, I think with WordPress, it's probably that is the most commonly hacked platform in the world today. Not because it's less secure, but it's just the most popular, and it's also the one where folks rely on the greatest number of third-party plugins. And almost every case where we see WordPress successfully hacked is due to either someone not keeping their code up to date, or someone not relying on a third-party product and not keeping it up to date. And even if they don't, when they don't have the intrusion detection and web application firewalls, it stop a lot of those vulnerabilities until the vendors have an opportunity to actually patch their code. But I wouldn't say there's any one system that is more secure or less secure. All systems have vulnerabilities. I can't tell you see more in .NET or PHP or Cold Fusion. They're really fairly even. The key is following the right processes, making sure that you're testing, making sure you're on top of these vulnerabilities, and stay up with your patches and have the right devices, between the attacker and the data. And when you do that, again, just by lowering your threat profile, you're much less likely to be a victim. But I can't say that just because you're on Cold Fusion, you're more or less secure, versus PHP, you're more or less secure. It's all the same.
Right, partly because they're all vulnerable to attack in some way or another, and in addition, it's not just the application server. There are so many other levels that the hackers get in through that I'm really glad you've been able to cover in this webinar. So we've got a couple other questions. I'm just going to combine them into one from Arnold and Russ. So asking if using VPN or SSD can help with the remote desktop protection, and also if proxying Cold Fusion requests would help in some way.
Proxying, I don't know if we really have any folks doing that. I can't tell you I've seen that be a huge win, because at the end of the day, it's still passing through IIS or Apache or something else. I mean, if you have, let's say, Apache with mod security, you're kind of doing that already. But just having an extra proxy in the way, it can help a little bit, because then it only passes certain kinds of requests to the server. But we found that ultimately it doesn't drive that much better outcomes. Having VPN or using SSH is just absolutely critical. And even with SSH, we don't really even expose SSH to the outside without VPN, because after RDP, the second thing that the attackers try to brute force is SSH. So we typically always start with the VPN first approach. And after VPN is the only way you can then have some mechanism exposed that can provide remote administration services on a machine. But just because it's SSH and encrypted doesn't mean it's safe, because someone can just sit there and brute force SSH all day long until eventually they'll guess your password if they really want to get in bad enough.
And Ross is making a comment that Cold Fusion runs as a service, whereas PHP runs as a process, and he's saying that makes it potentially more secure if you set up your server correctly. You have any thoughts on that? Or?
I agree with him 100%. So if you set up Cold Fusion to run in the context of a lower privileged user, and at the same time, let's say you go into IIS or Apache and set that particular website, let's say an IIS in the application pool, to run in the same lower privileged user, you again reduce your threshold for what an attacker can gain access to should he ever compromise your application. And a lot of